Hello, and thanks for attending this presentation at OW2online. My name is Virgile Prevosto. I'm a researcher at CList in Saclay, near Paris, and I'm acting as the technical leader of the H2020 DECODER project that I will talk about. DECODER stands for Developer Companion for Documented and Annotated Code Reference, and you can of course find more information on its website. It started at the beginning of 2019 for a duration of 3 years, meaning that we are currently in the middle of the project. The main aim of the project consists in providing a unified platform which will let users manage all kinds of information on a software project, including of course the source code itself, inline comments, documentations, models, test scenarios and results, formal specifications, and or static analysis results. DECODER has identified 3 main roles for its intended users, namely developers, reviewers, and maintainers, but the platform has the ambition to be useful for any stakeholder during the whole life cycle of a software project, from design to deployment to maintenance and upgrade. DECODER is coordinated by Technikon in Austria, with support from CList for technical leadership. Very roughly speaking, it will mix software modeling and analysis tools, notably from CList and UPV, the University of Valencia in Spain, with natural language processing tools, again from CList and Tree Technology, again in Spain. Making the best use of the platform will of course require defining some methodology, a collective effort led by UPV, while Capgemini in Spain provides its expertise in UX design to develop a user interface for the platform. Finally, the whole product will be assessed against various use cases in C, C++, and Java, provided by Capgemini, Tree Technology, Cisco in Germany, and OW2 in France, with also coordinating the communication efforts of DECODER and hosting us today. At the core of the project lies the elaboration of the Persistent Knowledge Monitor, or PKM, a database meant to host all the relevant documents for a given software project, as mentioned before, during the whole life cycle of said project. The PKM itself will of course come with tools for feeding the database and retrieving information from it. Within the project, this will notably be the case for natural language processing tools able to extract information from existing documentation or from the code itself, and to provide valuable insight on what the code is supposed to do, including potentially in the form of formal specifications. Similarly, static and dynamic analysis tools such as Pharmacy, OpenGML, or Tester should be able to take into account those additional sources of information in order to refine their analysis and to give back the results to the PKM. Finally, all such information should also be made directly available to end users through their favorite ID or a dedicated interface developed within the project, or through the generation of new documents, PDF or Word or other formats, UML models, or other kind of documents. Of course, in order to make all these tools communicate smoothly with the PKM, some common schemas have to be designed. In fact, since the PKM is such a central piece of the project, its design and the development of its first prototype was one of the major objectives of the first half of DECODER. For that, we gathered requirements from all partners in order to ensure that the database would cover as much as possible the needs of all its intended users. As we needed it to store very heterogeneous documents, document-oriented, NoSQL database was an obvious choice, and we finally settled on MongoDB, or at least its latest HGPL version 3.4 for the time being. JSON will be the primary format for exchanging documents with the PKM, and first schema has been proposed, with which we will try to adhere to existing standard proposals in the areas where they exist, such as for static analysis results, SARIF, for storing compilation information, JCDB from CMake, or for interactions with the IDE, the Language Server Protocol, LSP. At the lowest level, interactions with the PKM are conducted through MongoDB's own JavaScript driver, on top of which we have designed a lower level API, which is currently ready, to let the tools involved in the project feed the PKM with their own data, and to make basic queries to the PKM. Currently under design, there is an higher level API which is more suitable for end users interactions. And again, under design, we find a web-based interface to manage the PKM. Another very important aspect of the project is the usage of natural language processing techniques to automatically identify correspondences between the documentation and the corresponding source code. Knowledge extractions could be done in both directions, either to derive more formal requirements from an English, French, Spanish, German document, or to help writing the documentation by extracting directly some part of it from the code. In this area, the first part of the project has been dedicated to gather datasets in order to train the models and to the training itself. For that, existing datasets external to the project have been identified and used, as well as the use cases of the projects, notably the ones in Java and C++. Initial experiments are encouraging in the direction from code to natural language. Focus was made on grouping tokens according to their lexical values, with a first application towards detecting potential misuse of identifiers. For instance, if a developer used an X where it would have been more natural to find a Y, either in the code or in a comment near the code. In the reverse direction, from natural language to code, the idea is to use neural machine translation techniques, in which the code will simply be seen as another foreign language. Models are currently trained to compute a similarity level between the source and the corresponding informal description of what the code is supposed to do, again with interesting results. Last but not least, some work has been dedicated to define the so-called abstract semi-formal models, or ASFM for short, where the idea is to provide a kind of graphical language which would allow describing the effects of a function on the data structures involved. For instance, when we have lists or trees or graphs. Such format could act as an intermediary between the source code and formal specifications on the one hand, and natural language descriptions on the other end, hence his name of semi-formal. It would also thus constitute a convenient target for natural language processing tools as an intermediary towards generating formal specifications, which might be difficult to attain directly. Furthermore, it is also planned to add a graphical debugger that would let users play with SFM objects in order to better understand the behavior of the underlying program and the data structures that are supported by ASFM. Currently, a first version is available with a common core which is understood by each tools in the platform, and in some places some tool-specific extensions. All in all, ASFM provides some kind of an abstraction layer on top of the PKM's lower level representations of the code in particular, and to some extent can be seen as a part of the higher level API. In addition, prototypes for creating ASFM models from the code are currently available. To summarize the work done so far, we are approaching the point where the PKM server will be available for extensive beta testing. First, internally, notably to refine the functionalities that are offered both by the low-level API and the A-level API, which is currently under design, and to complete the bindings with the client under development. Similarly, we also have to finalize the integration of the NLP tools within the PKM. After that, it will be time to open up beta testing to external, possibly some kind of adventurous users, including interfacing with other tools, or simply let users play with the graphical interface available. For that, it might be interesting to use the reach out platform that has just been presented, but currently this is still under discussion within DECODER. And this concludes what I wanted to tell you about DECODER. So thank you for listening, and feel free, of course, to contact us if you want more information.